Okay, today we will take a TEKTRONIX optical isolator with our ZLPROBE isolation probe to make a constant comparison. The model of TEKTRONIX light isolator is TIP. This is the model of TIP1. This is the model of ZLIP 200, 200 megabits. Let's just make a comparison. This is a gallium nitride half-bridge tester. It is connected to the VGs of the upper bridge. Because there is a relatively high-frequency common mode. In the case of high common mode, we will measure the differential signal. Now the voltage is set at 400 volts. Then we turn on the signal. This is a driving signal for the upper tube VGs. Then we mainly look at the common mode. Let's expand it to see. We can see that after expansion, the fluctuation and signal. This is a model of Miller plateau. In this case, it has a better common mode rejection ratio. So Miller plateau effect is still relatively ideal. There is no such thing as using differential and a large interference. Then let's compare the two platforms' performance of low noise. Our one has 3 gears. After testing different signal sizes corresponding to different signal sizes. For example, when we test, let's say we're testing a small signal. Okay, in the case of a small signal, for a signal of a few hundred millivolts, we can use the first gear. After setting to one layer, the input is 1 volt. So for oscilloscopes, it can be directly set it to a very small value. Thus, set the oscilloscope probe attenuation to 1x. Also shift the TEKTRONIX scope to the center. Okay, now let's look at the same. When the volt is 20 millivolts per grid, we also grind our shoulders, which is the bottom noise. We can see when testing small signals, we set it to one setting. There is a good noise. In this case, when testing small signals, it will have a better signal-to-noise ratio. In case, suppose we are going to test a 200 millivolt signal. We set it to 50 millivolts per grid. Then we can take a look. If we test a 200 millivolt signal, if we use one setting, the noise will be better. So for this product, the reason for setting 3 gears is it will be better. We can use the small gear when the amplitude of the signal is large. We can use the corresponding 10 setting. The input voltage is 10 volts, and the ratio is also set to 10 times. We can see if the function of the 10x setting, it is mainly used for testing, such as 3.3 volts or 5 volt systems, which is a signal greater than 1 volt and less than 10 volts. On this signal, our oscilloscope is usually set to. Is it okay to set it to 500 millivolts per grid? As you can see, in fact, in the case of 500 millivolts, in fact, the noise of both have little effect. The two noises are basically the same. That is to say, at this level, measuring a few volts signal, the impact of noise is basically very small. So when we look at the noise floor, we basically compare the influence of measuring millivolt signals So in order to increase the function of measuring, add measuring millivolt signals, we have added a ratio of 1 times 1. Of course, this is connected to the 10 times the influence of the millivolt signal. If you connect it directly, it will be a 0.1 times gear. To test signals of several millivolts, it is mainly used for on-the-channel shunt resistors, the current, and some environments, to reduce the sampling and voltage buildup. Then let's test it now. Is the gallium nitride half-bridge circuits the common mode situation of the neutral point? The test board is connected to the positive and negative poles of the probe, which is equivalent to simply measuring a common mode signal. Then let's take a look at this. The common mode situation in this case. Okay. Now we can get a common mode. We can see that this position is a place where a common mode signal, and we can see that actually this one may be better than TEKTRONIX's. We can see a signal, but our signal is basically in a noise. Of course, it may also be that this light, the light has been used for a long time. We can see, overall, let's take a closer look at the entire graph. We can see that there are still some common mode noise. Of course, it could also be this. The common mode connection point of the board is not particularly ideal. As we can see from the expansion just now, there is a fluctuation, but actually, these two models look like the noise is actually very small. Under 400 volts, it should. Its fluctuation is only a few tens of millivolts. We can look at the bouncing of this card. As we can see, its peak-to-peak value is 67 millivolts. That is to say, it is equivalent to a 400 volts. A 1,000 times different. That's all for today's test. Thanks for watching.